Hi, I'm Susan, and welcome back to our second video on automatic film processing. In this lesson, we'll explore the transport system of an automatic film processor and examine its major subsystems. These include the feed tray, the entrance rollers, the roller assembly, the crossover rack, the squeegee rollers, and the drive motors. By the end of this video, you'll have a clear understanding of how these components work together to move the film smoothly through each stage of the processing cycle. Let's get started. In automatic film processing, the feeding tray is the starting point of the processing cycle. It plays a vital role in initiating a series of automated actions that ensure the X-ray film is properly developed. Once a film is placed on the feeding tray, it is guided into the developing tank, and several internal systems are activated in a coordinated sequence to support effective film processing. The feeding tray is where everything begins. It is the starting point of the whole process and plays an important role in making sure an exposed X-ray film is properly developed. The radiographer places the film on the feeding tray, which is located at the entrance of the developer section. From here, the machine takes over. Once the film is detected, the processor automatically starts a series of coordinated actions that move the film through different stages of development. As soon as the film enters the feeding tray, several systems are activated one after the other. First, the replenishment system is switched on. This system adds fresh developer and fixer solutions to keep the chemicals strong and effective. Next, the safe light above the tray is turned off to prevent any unwanted light from affecting or fogging the film. Then, the drive motor starts working. This powers the rollers that carry the film through the processing tanks, including the developer, fixer, wash, and dryer sections. At the same time, the wash water flow increases to ensure the film is properly cleaned and free from chemical residues. An audible alert, such as a bell or buzzer, also sounds. This signals that the machine is ready for another film and helps prevent overloading or film jams. Finally, the dryer heater switches on to prepare the film for drying as it moves out of the system. When no films are being processed, the machine stays in a standby mode. In this state, most parts of the system, like the roller drive, remain inactive until another film is inserted. Now that we've explored the feeding tray, let's move a little further inside and take a closer look at the entrance rollers. Entrance rollers are the first set of rollers in an automatic film processor. They are located at the point where the exposed X-ray film enters the processor. Once the film reaches the entrance rollers, they immediately grip it with just the right amount of pressure and guide it smoothly into the developer section. This precise movement keeps the film perfectly aligned, preventing misalignment, damage, or frustrating paper jams. By feeding the film at a steady, controlled speed, the entrance rollers ensure that every stage of processing happens at exactly the right time. From here, the film embarks on its journey through the processor. A series of rollers and roller racks transport it through the developer, fixer, and wash tanks before carrying it into the drying chamber. Once the film has been fully processed and dried, it is automatically delivered into the receiving bin, ready for viewing and diagnosis. The roller assembly in an automatic processor is a system of rollers that moves the X-ray film through the different processing stages. It ensures smooth, continuous transport of the film at a controlled speed. The rollers also help agitate the chemicals, improving contact with the film for even processing. The roller assembly consists of 3 types of rollers. 1. Transport rollers. 2. Master rollers. 3. Planetary rollers. Now, let's take a closer look at the transport rollers. These rollers are arranged in pairs, lying directly opposite one another, and their primary function is to keep the film on the correct path as it moves through the processor. They also maintain the correct speed, pressure, and alignment of the film throughout the entire processing cycle. This ensures the film travels smoothly without slipping, jamming, or becoming misaligned. But that's not all. The transport rollers also assist in chemical agitation, allowing fresh processing chemicals to flow evenly across the film's surface. This helps ensure the film is properly developed while preventing streaks, uneven processing, or damage. Although they may seem like simple components, transport rollers play a vital role in producing a high-quality diagnostic radiograph. The turnaround assembly consists of 3 main components: the master rollers, planetary rollers, and guide shoes. These components are located at the bottom of the transport rack assembly. As the film reaches the section, the master rollers work together with the planetary rollers and guide shoes to smoothly guide it through a U-turn. This redirects the film upward toward the top of the tank, where it is transferred to the crossover rollers for the next stage of processing. This coordinated movement ensures the film travels smoothly through the processor without bending, jamming, or damage. The crossover rack is a part of an automatic film processor that helps transfer the film from one tank to the next, usually from the developer to the fixer, and from the fixer to the wash tank. It contains a set of rollers and guide plates that lift the film out of one solution and guide it into the next without slipping or damage. The crossover rack ensures smooth, accurate movement between sections, maintaining proper film orientation and preventing contamination between chemicals. Squeegee assembly or squeegee rollers removes excess water from the X-ray film. Now that we've explored the transport system and its components, let's quickly summarize how an X-ray film moves through an automatic film processor. The process begins when the exposed film is placed on the input tray. The entry rollers pull it into the processor and transport it through the developer, fixer, wash, and drying sections. Once processing is complete, the film exits through the output tray, fully developed, dry, and ready for viewing. This smooth movement is made possible by a series of rollers arranged in removable racks for easy cleaning and maintenance. Where the film needs to make sharp turns, such as at the bottom of the tanks, guide plates work alongside the rollers in the turnaround and crossover assemblies to keep the film moving without slipping or damage. The entire transport system is powered by a DC motor through a network of gears, ensuring every roller moves in perfect synchronization. For safety, the roller drive automatically stops whenever the processor lid is opened. Different rollers serve different purposes. Rubber rollers provide extra grip where the film changes direction, while squeegee rollers remove excess solution between tanks to reduce chemical carryover. The remaining PVC rollers guide the film smoothly through each stage, ensuring consistent, high-quality image processing every time. Before we wrap up, let's take a quick look at two important concepts: processing cycle time and processor capacity. The processing cycle time, also known as the dry-to-dry cycle, is the total time it takes for an X-ray film to travel through the processor, from the moment it's fed into the input tray until it comes out completely dry and ready for viewing. In most medical imaging departments, this process takes between 90 and 115 seconds, making it a rapid processing cycle. During a typical 90-second cycle, the film spends about 26 seconds in the developer, 15 seconds in the fixer, 15 seconds in the wash section, 24 seconds in the dryer, and 10 seconds moving between sections. Some automatic film processors allow the processing cycle to be adjusted by changing the film's transport speed. This provides flexibility when using different film types, developer solutions, or processing temperatures. However, once a processor is installed and properly calibrated, the cycle time is rarely changed during routine use. Processor or production capacity refers to the ability of a film processor to handle a certain number of radiographic films within a specific period of time. It is a key factor in medical imaging because it determines how quickly diagnostic images are produced and made available for review. Manufacturers express processor capacity in different ways. First, it may be stated as the number of single-size films, usually 35 by 43 centimeters, that can be processed in 1 hour. This gives a standard measure for comparing different machines. Second, it may be expressed as the number of mixed-size films processed per hour. This is often more realistic because imaging departments handle a variety of film sizes in daily practice. Third, capacity may be described using film feed time, which is the speed at which a film travels through the processor. This is usually measured in centimeters per second or meters per hour and reflects how fast the system operates. Manufacturers also provide the total processing time for a single film, such as 90 seconds. This includes all stages: development, fixing, washing, and drying. In fast-paced environments like accident and emergency units, speed is critical. Many films may arrive at the same time, so a high-speed processor helps reduce delays and improves patient workflow. For example, A high-capacity processor operating on a 90-second cycle can handle about 250 films of 35 by 43 centimeters per hour, or around 450 mixed-size films. In contrast, a low-capacity processor may handle about 70 standard films per hour, or about 125 mixed-size films. Understanding processor capacity is essential when selecting a machine that matches workload demands and ensures efficiency in clinical practice. Thank you for listening. See you in the next video.